We're now going to discuss types of variables. This is important because when you do statistics, oftentimes the method you choose is going to depend on the type of variable that you're dealing with. Now, in this class, you're not going to really ever have to make that decision. So they're always going to, when they ask you to do a certain method, they're going to give you the right type of data. But if you were an actual statistician, that would be something you would need to know. You would need to know the different methods and what type of variable you're dealing with. And so they want to introduce you to this idea. So first of all, a variable is something that you're interested in studying, and something that you observe that you can get a value from, and it varies from person to person in the population. Like I could go to each student here and ask you what your grade point average is, okay? And that's going to vary from person to person. So we would say that that's a variable. And the way we get data is by actually observing the value of that variable. So if I go to one of you and ask you your grade point average and you tell me it's 3.2, then that is a piece of data in my data set. And if I asked everybody in the class, and then I would get a data set, that would be the values of the GPAs for all the students in the class. Okay, so now when we're dealing with different types of variables, okay, so there's a main division. The first division here is that your variable can either be qualitative or it could be quantitative. Okay, now the word quantitative makes you think of quantity, like, and let me see if I can focus that. There we go, a little better. So it makes you think like number, numerical, and you'd be right. So the quantitative variable, these are the numerical variables. Okay, these are variables. When you observe the value of the variable, you get a number, and it's something that you can add together or average or divide or whatever. You know, you get a quantitative value. Okay, now when you look at this word qualitative, you think of the word quality, like the different qualities that people can have, like, you know, whether you're you know, a freshman, junior, senior, you know, something like that, or whether you're Republican, Democrat, Independent, or whatever you're dealing with. But the point here is this is non-numerical data. So like political party, marital status, ethnicity, whatever. Okay, these are qualitative variables. Okay, now the quantitative variables are going to break down here into two more categories. For quantitative variables, you can either have a discrete variable or a continuous variable. Okay, so the difference between these discrete variable, these are discrete points on the number line. So if you have like 0, 1, 2, 3, okay, these are points that are all by themselves on the number line, and you're jumping from point to point, and there's a gap between them. So oftentimes a discrete variable is when you're counting. So when you're doing a discrete variable, think counting, and that'll usually lead you in the right direction when you're trying to identify the variable. Whenever you're counting something, that's a discrete variable. Now a continuous variable is a variable here that it's continuous along the line. It can be any value. Okay, so it's not just these discrete points, but it's any number along the line, and it can stop anywhere in the interval. And we always, I mean, technically we say there's actually an infinite number of places between any two numbers on the line, because I could, I could have 1/2, 1/10, 1/100th, 1,000th, so on. And we don't really put a limit to how small we can get. Okay, and so a continuous variable is a number that could be any number on the number line. And what you should think here is think measuring. And then this think measuring, this will usually lead you in the right direction here. Okay, so let's do some examples. So you might have, number of classes that you're taking, or maybe number of credit hours, or how what's another? I want to think of an example where I don't have to say number of this, number of that. I'm not sure. So number of classes, number of people. I'll just leave it at that. What we'll see in there in the example that we're going to do in a second is that when you're dealing in a certain currency, the cost of something is going to be discrete. Okay, and I'll talk more about that in a minute. I was going to say, you might have something like shoe size, because you have like 9, 9.5, 10, 10.5. And what makes that interesting is you not only are you not saying number of, but you actually have points that are halfway between. But these are still discrete points on the line, and I have to jump from 0 to 1/2 to 1 to 1.5 to 2. So 9 to 9.5 to 10 to 10.5. So that would be, but that's a very unusual example. And technically, when it's shoe size, in a sense you're measuring. It's just that we only measure in whole numbers and halves, and so they're discrete. But basically, you're in discrete variables. Usually you think counting. Okay, so I might even cross that off, because if you're actually measuring the shoe size with a ruler, then you're actually measuring. Okay, and so basically, the length of something, something's weight, the volume of something, the distance something travels, the amount of time. Time is a continuous quantity. The temperature of something. These are all continuous quantities. In the temperature, think of a thermometer where the mercury rises through the thermometer. It actually goes through every number. It's continuous. It doesn't jump 1 degree at a time. It doesn't jump discretely, right? The mercury has to rise up the thermometer and technically take on every value as it goes up the thermometer. And so these are continuous quantities, okay? So with that in mind, here's an activity, and what I want you to do is I want you to decide, first of all, whether they're qualitative or quantitative, okay? And if they're qualitative, you're done. But if it's quantitative, then I want you to decide whether it's discrete or continuous. Some of these are going to be a little more difficult, and the reason for that is it'll bring out a few more nuances. But for the most part, the homework and the tests, we're not throwing difficult examples out at you. We're just testing to see if you know the difference between these types of variables. So go ahead, press pause, give it your best shot, and then start the video back up again and see how you did. Okay, so let's go ahead and look at these. It says the time it takes to read chapter 1 of your stats textbook. Okay, well, time is a continuous quantity. So the thickness of chapter of your stats textbook, how thick it is. And now here you're measuring, right? How long, the length, or, the thickness. And so that's a continuous quantity. Now the number of pages in your stats textbook, that is a discrete quantity. You're counting the number of pages. The topics covered in chapter 1 of your stats textbook, that is a qualitative variable. Okay, so it's non-numerical. Now this is an interesting one. The edition of your stats textbook, like this is like the 8th edition, I think, or the 10th edition or something. 8th edition. Okay. If you said quantitative discrete, I understand why, because you have like the 1st edition, 2nd edition, 3rd edition, kind of like you're counting the edition, and those are kind of numerical in our minds. And so I get that. But actually, as it turns out, the edition of your stats textbook is actually a qualitative variable. And here's why that is in order to be quantitative, then you need to be able to add and subtract. That needs to make sense. Or you need to be able to average. Like if I need to be able to do like math on it. So if I had, let's say, the 8th edition, and if I say I'm going to subtract the 5th edition, that doesn't give me the 3rd edition. Does that make sense? That doesn't make any sense. Okay, so you can't, or I can't take and average the additions and that be meaningful. Another example might be zip codes. Like you never take a group of zip codes and average them and find like the average location or something. That doesn't make any sense. Or you don't ever add 2 zip codes together. That's not a meaningful quantity. Or subtract 2 zip codes. So actually, even though zip codes are numbers, they are numbers being used to name different regions. And that's a qualitative variable. So a few numerical looking variables can be qualitative, and the way you know is that doing math on them doesn't make any sense. Adding them or subtracting them or averaging them. Okay, so that one was a little tricky, but edition of stats textbook is qualitative. So what about the temperature of your stats textbook in degrees Celsius? And that is continuous. And then it asks, what about degrees Kelvin? That's going to make more sense when we get to the scales of measurement. But in this case, it's still continuous. Temperature is always a continuous quantity. Okay? But these have 2 different scales. So the scales of measurement are going to be different. But in either case, they're both continuous. The amount of money you paid for your stats textbook. This is discrete, okay? And the reason for that is in America, we use a certain currency, and a penny is the smallest currency we use. So if your textbook was, let's say, $79.98, right? That's kind of like counting pennies. That's like 7, what is it? It would be like, let me say $1.98. That would be like 198 pennies. Does that make sense? And you're counting pennies, but you're just referring to them in dollars. $1.98, and that's different than $1.99. But you're jumping from 98 to 99, and technically, something like if you had if you had let's say a euro or something, that might, when you actually exchange it, it might fall between $1.98 and $1.99, and you would have to round, right? So money as a theoretical quantity, like when they do finance and stuff like that, it is a continuous quantity theoretically, but once we deal in a certain currency, then it becomes a discrete quantity. And you're counting, in the case of American money, pennies, and in other currencies, that measure, or that amount of the smallest quantity is going to be different. So again, that's another one that's a little tricky. Okay, so opinion of your stats textbook on a scale of 0 to 10, with 0 being strongly dislike and 10 being strongly like. Now this one could be either one depending on how you were thinking of it. Okay, and so let me give you an example. When I did eHarmony, they had examples where it was like a mouse click, and maybe 1, 2, 3, 4, 5, and I had to give my opinion of something, and so I had to click on one of these. And in that case, that would be discrete. Okay, so but other ones, they had kind of a slider bar here, and then I was able to take my mouse and move this along the slider, and this might have been 0 and this might have been 5, and I just moved the slider bar to where I felt like I was. Okay, so this would be kind of discrete from 0 to 10, or this would be continuous. So it depends on how you think of the scale in that case. The ones that are in the homework should be pretty clearly one or the other, though. Okay, but that's an interesting one that makes you think. So that is discrete or qualitative, quantitative variables, discrete and continuous. So in a little bit we're going to talk about boundaries, but then in a little bit we'll also talk about scales of measurement, which is something completely different.